Hello everyone and welcome back to my channel. Today we're going to be doing an overview of Initramfs in Linux. Initramfs, Initial RAM File System, is a crucial component in the Linux boot process. It serves as a temporary root file system that is loaded into memory during the early stages of booting. This file system contains essential drivers and tools needed to mount the actual root file system and start the user space kernel. Why Initramfs is used. Modular kernel support. It allows the kernel to remain modular by loading necessary drivers at boot time, especially for file systems and hardware that may not be available in the kernel itself. Early user space. It provides a minimal user space environment to execute scripts and commands before the main system is fully operational. Flexibility. It can be customized to include specific drivers or tools needed for particular hardware setups, making it adaptable for various environments. Regenerating your Initramfs. This tool is dependent on your distro. Update-initramfs would be for Debian, Ubuntu, Mint, etc. Dracut, available on a wide variety of distros but common on Fedora, Red Hat Linux, and etc. mkinit CPIO, most commonly on Arch Linux, Manjaro, Endeavor, Artix, etc. Common problems solved by regenerating Initramfs. Regenerating the Initramfs can resolve several issues, including boot image not found. This error occurs when the bootloader cannot locate the Initramfs image. Regenerating it ensures that the correct image is available. Missing drivers. If hardware drivers are not included in the Initramfs, the system may fail to boot. Regenerating it with the necessary drivers can fix this. File system corruption. If the root file system is corrupted, regenerating the Initramfs can help by providing a clean environment to attempt repairs. EFI partitions and boot process. The EFI, Extensible Firmware Interface partition, plays a critical role in modern boot processes, especially on UEFI systems. Here's how it interacts with the bootloader and Initramfs. Number 1. Bootloader from EFI stub. The bootloader, such as grub or systemd-boot, is loaded from the EFI partition. This bootloader is responsible for loading the kernel and Initramfs. Loading initrd. The bootloader locates the kernel and the associated Initramfs image, often referred to as initrd, specified in its configuration. It loads both into memory. Handing off to kernel. Once the kernel is loaded, it initializes the system and mounts the Initramfs as an initial root file system. The kernel then executes the init process, which transitions control to user space. Transition to user space kernel. After the kernel has initialized and mounted the Initramfs, it executes the init process, usually /init, which is responsible for setting up the environment. The init process prepares the environment for the main system by executing scripts and loading necessary modules. Mounting the real root file system. It eventually mounts the actual root file system, e.g. from the hard drive or SSD, and transitions control to the main user space system. This handoff is crucial for a successful boot, as it allows the system to move from a minimal environment to a fully operational state. Init process, systemd, and run it. The init process is the first user space program that the Linux kernel executes after booting. It is responsible for initializing the system, managing services, and handling system states. Two popular init systems are systemd and runit. each with its own approach to managing system initialization and service supervision. Handoff from initrd to /init. During the boot process, after the kernel has loaded, the initramfs initrd, it executes the /init script or binary found within the initramfs. This is a critical transition point where control is handed off from the kernel to the user space environment. Number 1. Loading initrd. The kernel mounts the initramfs as its initial root file system. This file system contains the necessary tools and scripts to prepare the system for the main user space environment. Number 2. Executing /init. The kernel looks for the /init executable within the initramfs. This can be a shell script or a binary depending on the configuration. The execution of the /init marks the transition from the kernel's boot phase to the user space initialization. Handoff from initrd to /init. 3. The system initialization, the /init process, is responsible for setting up the environment, e.g. mounting file systems, loading modules, starting essential services and processes, transitioning to the main init system like systemd or runit. Init systems. The init system /init has a process ID 1 and spawns all other processes. It is the root of all daemons, background processes. It manages things like the display manager, audio servers, graphics server, like Zorg or Wayland. Essentially, it does everything. Systemd. Overview. Systemd is a modern init system that has become the default for many Linux distributions. It uses a unit-based approach to manage services, dependencies, and system states. Features. Parallel service startup. Systemd can start services in parallel, improving boot times. Dependency management. It tracks dependencies between services, ensuring that they start in the correct order. Socket activation. Services can be started on demand when a request is received, reducing resource usage. Transition from initrd after /init. It executes. It typically invokes systemd as the main init process. This is done by executing exec /lib /systemd, which replaces the current process with systemd, allowing it to take over the system management. Runit. Overview. Runit is a simpler and lightweight init system that focuses on the service supervision and management. It is often favored for its simplicity and speed. Features. 3-stage initialization. Runit uses 3-stage process. The first stage initializes the system, the second stage manages the services, and the third stage handles system shutdown. Service supervision. Runit continuously monitors services and restarts them if they fail, ensuring high availability. Transition from initrd. Similar to systemd, after the init /init script completes, completes its task, it will execute runit as the main init process. This is typically done by executing exec /sbin /runit, which takes over the process management. Others. OpenRC, used on a variant of Artix, Linux, and Gen 2 systems. S6, also an option on Artix and Gen 2. Summary of the handoff process. The handoff from initrd to the main init process, either systemd or runit, is a crucial step in the Linux boot process. Here's a brief overview of the transition. Number 1. Kernel loads initrd. The The kernel mounts the initramfs and executes the /init script. Number 2, /init prepares the system. The system /init script sets up the environment, mounts the file systems, and prepares for the main init system. Number 3, executes main init. The /init script executes the main init system, systemd or run it, replacing itself with a new process. Number 4, system management. The chosen init system takes over, managing services, handling dependencies, and ensuring the system is operational. For more sources on this, I've put some links here so you can check out anything else you need here. Thanks for watching my video. Please like and subscribe.